Experts from different fields come together, harmonizing their distinct sounds into one, to mark the fini of a long and fateful concerto. In 1906, Russia, biologist Alexander A. Masksimov. At the Berlin Hematology Conference, the term stem cell was used for the first time, and the hypothesis was proposed that various cells that make up human blood originate from a single progenitor cell. 1963, Canada. Biologist Ernest A. McCulloch and James E. Till. It was suggested that the bone marrow cells transplanted into mice exhibited clonal properties and originated from a single cell. 1973, Russia. Biologist Alexander Friedenstein. A method for ex vivo culture was devised to study the clonality of multipotent bone marrow cells, leading to the discovery that mesenchymal stem cells exist in the bone marrow. 1991, USA. Biologist Arnold I. Kaplan. The term MSC was first used, and a significant contribution was made in uncovering the mechanisms by which MSCs regenerate damaged tissues in the body and regulate inflammation. Through ongoing research, it was later discovered that MSCs not only regenerate tissues but also possess immunomodulatory properties, regulating inflammation and immune responses, opening the possibility for MSCs to be applied to inflammation-related diseases. In addition to these findings, the research of many other biologists has shed light on the capabilities of stem cells, fostering the belief that stem cells could become a revolutionary next-generation cell therapy for treating incurable diseases. Among them, mesenchymal stem cells have gained particular attention for being safe and known for their secretion of immunomodulatory factors and anti-inflammatory effects. In 1995, MSCs were first tested as a cellular medicine in humans by Hilliard Lazarus, and since then, they have become the most clinically researched experimental cell therapy platform worldwide. However, they have yet to receive marketing approval in the United States. The reason why the commercialization of MSCs has not yet been active is due to their heterogeneity. We address the issue of heterogeneity from three perspectives: the issue of variability in the differentiation potential, proliferative capacity, and immunomodulatory effects of MSCs, even between different donors or within the same donor. This variability leads to inconsistent clinical outcomes during clinical applications. The heterogeneity creates challenges in standardizing MSC production. In order to prove the reliability and effectiveness of MSC-based therapies and enable commercialization through regulatory approval, the issue of heterogeneity must be resolved, and this is our challenge. How can we overcome the challenges we face? Capo, from the beginning. Having studied MSCs from a full-cycle perspective for 18 years since 2005, we have found a clue to solving our shared problem. We went back to the very beginning, starting again with the isolation method, the first step in obtaining MSCs. Subfractionation culturing method is a process where culture medium is added to 1 ml of bone marrow, and after allowing an appropriate amount of time, only the supernatant is transferred to a different culture vessel. This allows for the separation and cultivation of cells with different sizes and densities from the single-cell stage. After 10 to 14 days of culturing, cell populations derived from single cells can be obtained, and the marked colonies are individually separated using colony cylinders. At this stage, each colony becomes a single cell line. Subsequently, the cell lines are passaged to establish a master cell bank, and the cell lines are selected through characterization processes such as FAC analysis, cell surface markers, differentiation potential, and T-cell suppression capability. Unlike traditional isolation methods, subfractionation culturing method allows for the acquisition of cell populations derived from single cells. This enables the analysis of each cell population and the creation of a library with the confirmed stem cell lines. Additionally, we have always recognized the importance of not only isolating stem cells but also the large-scale production of MSCs from a commercialization perspective. Through joint research with PBS Biotech, we have established a large-scale MSC production process using 3D bioreactors. The 3D process utilizing 3D bioreactors is specialized for MSC commercialization, as it can produce more than 10 times the number of cells compared to the conventional 2D process. We believe that through the SCM vial, we can unlock new possibilities for MSCs. However, this journey is one that cannot be undertaken alone. Just like an orchestra, where each player contributes their sound through their instrument, harmonizing to create a beautiful melody, we too must come together in unity. Our symphony, created together, not as individual soloists, will produce a truly harmonious and beautiful melody, making the sound of hope, once only imagined, a reality. Da capo al fine, to move from the beginning to the end. Now, as a symphony, we must start again with the SCM viol and play the final note of the great symphony of MSc regulatory science advancement and commercialization. Through the true MSc and the clusters we have encountered, let us become a symphony, playing together to achieve our common goal and create a harmony of hope that no one has experienced before, but which the world truly needs.